Welcome to week one. This is chapter one. We're going to go through this presentation pretty quickly, mainly because most of the stuff is in the book. I only want to cover like the top pieces to kind of give you some sense of direction, but these presentations are not meant to replace you going through the book and reading the book, and mainly because, again, the book really does go into some better detail that if I were to try to go through, these videos would be hours and hours long. So please understand that this is just a supplement to the book. Make sure you're reading the book. All right, so let's get started and go ahead and talk a little bit about the fact that your book has, I think it's three different kind of data examples that we're going to be using. A lot of times you're going to see information about the TAL distributors. You're going to see Colonial Adventure Tours, and you're going to see the Solmaris condominium group. We will, for our homework, be using the Colonial Adventure Tours. And with that being said, oftentimes our examples will be using the TAL distributors or the Solmaris condominium group. So that way we're not just giving away the Colonial Adventure Tours assignments. I mean, don't get me wrong, on the homework videos that I go through, because I'm trying to work with you on the homework, I will make use of the Colonial Adventure Tours as well. But when we're just doing examples, oftentimes we're using the TAL distributors or the Solmaris the condominium group. And by the way, it's not the first time I something about the Solmaris condominium group. I will call it the Solmaris comedian group a lot of times, just because to me it's the data is a little funny. But anyways, nonetheless, that's kind of where we're at with the data. So what is a database? A database is a structure containing categories of information and relationships between these categories. So remember that categories are what we're going to call tables down the road, but they're actually known as categories. They're sales reps. You've got maybe some customers. You maybe have a category of orders. Think of all the things you could have categories about. Maybe you have, let's say you're building a database in regards to movies that you like to watch. Well, you know, you would have ratings maybe as a category. Maybe you'd have genre as a list of as an actual category. So again, it's those big clumps of data. And like I said, in a little bit, we're going to start calling them tables. But databases are the relationships between categories. So that's the thing to understand, is if you had just one category, let's say you had an Excel spreadsheet and you're filling a bunch of data in there. Is that a database? Well, not truly, because you only have one set of data. It's only one category of data. Now, you might argue that if you started to make multiple sheets in an Excel document and have different categories on each on each tab, and those categories somehow have relationships between them, then yeah, you're probably starting to build a database. So kind of see it that way. It's a bunch of tables, but the important piece is those relationships between the tables. If we have a database with a bunch of tables and they're all over the place and they don't really have any relationship, then you don't have a database. You actually have just a gathering of tables. But because there's no real relationship, it doesn't mean anything. And that's where you see a database starting to form, is when the relationship between the categories makes something meaningful. Again, real top level, TAL distributor database. It's a wholesaler of wood toys, games, and puzzles. They have a manual system no longer feasible for managing customer order and inventory data. And so we're going to help them build a database management system that will allow for the current and accurate data with useful reports. In the TAL distributor, there are a bunch of categories, and one of them is the sales rep. And this is what you would see in the sales rep category for that TAL distributors. This is more data requirements for customer, required data for items, But let's take a look at this real quick. This kind of looks like an invoice. It's a form of a report. And what you're going to see here is we have these headings up here. But the real meat of the data is starting to where you have the customer, right? So we have this customer. They're going to be in a table. And then what they've ordered, these item numbers, and what that description is, all this data needs to be in the database. And it's all of what was made up of all these requirements that we just went through. So make sure you're looking at the book to get a little bit of a better understanding of what the tile distributors looks like. So the components of a sample order is that heading that we talked about. Go back here, we look at this, the tile distributor's header, which is going to be the same on all invoices, but the customer header, that's going to be slightly different. Oh, and we also have the sales rep over here. Again, it's part of the header information because it's kind of a one-to-many relationship, which we'll talk about later. But this is that header information. And then we have a body, which is this piece, which is the actual invoice data. It's the item numbers with the description, how many they've ordered, what that price was, and the total. And then with any good report, typically you have a footing, which is going to sum up the data. And in case, this is summing up the total. So what are the components of that line item? Well, we already talked about that a little bit. Each line item has a item number, a description, numbered ordered, a price, and then the total. So items stored for each order is that order number, the date of the order, the customer number, the customer information, along with the sales rep information. We talked about order numbers and the item numbers, the number of units ordered, quoted price. An item description is stored with information on orders. The order total is not stored, but is calculated each time order is displayed or printed. Let's take a moment to talk about that for just a brief moment. So we have all this data that we've been storing, which is the item number, the description, the number ordered, and the price. Now what you won't find typically in the data is the total. And that's because it would be redundant data. We can always figure out this total by multiplying this to this. So with that being said, why do we need to store this and take up space in our database? So most of the time, for many reasons, we're not going to store this data. Now, with that being said, I'm going to take a brief moment to say, especially for those that are in the class that already know SQL and probably work for a company doing SQL stuff, yes, there are always times where storing the total might make sense. Especially if you are wanting to run reports on large amounts of data and doing queries that would be specific to the total amount. So maybe I want to do a query that says, give me all of the line items that equal more than $200 in total, right? If you have a smaller data set, then that query could still do the calculation on number ordered times price and then do the query, and you wouldn't see a whole lot of time being wasted. But if you started getting into the millions of rows of data, then doing that calculation first before having then do the query could start showing some slowness in your data. So in that case, might be a good reason to put the total. So typically, like I said, try not to confuse you all, we would not store the total because it's an aggregate of existing data. Just like a lot of times, we're not going to store the total price because, again, that can be calculated by adding these two together. There are, again, just like I said before, there are some reasons why you might, but for the most part, for this class, you wouldn't. All right. So let's take a look a little bit about what a sample rep table would look like. Now remember, and I want to keep repeating this so that way when you are getting to certain questions on a test, you understand that the rep table is AKA, also known as the rep category. Remember, table and category are very interchangeable. And when you're talking about databases at a very high level, you tend to call them categories and not tables. But this is the rep table, and as you can see, we've got the rep num, the last name, the first name, the street, the city, state, postal code, commission, and the rate. So there's a lot of data here. This kind of goes over what we just talked about. Now let's look at the customer table. The customer number, the customer name, the street, the city, state, postal code, the balance, their credit limit, and their preferred rep number. So now, as it shows here on this customer table example, we got the Toys Galore, who happens to be number 126 now, has a sales rep of 15. So we can go back to the rep table, look at 15, and go, oh, that's this person, Rafael Campos. And we can go, okay, now I know who the rep is. But see how there was a relationship between the rep number, which is in the customer table, and the actual rep table? And it also goes the other direction. We can go and say, hey, tell me all the customers Rafael has, and we could go back here and we go, oh, well, we know that Toys Galore and Cards and More and Crest Store and All Seasons Gift have him as a rep. Now let's take a moment to talk about the sample item table. Item number. Now look at this item number. This is rather unique. It's got a couple letters and numbers where a lot of our other number fields were just integers. They were just numbers. But you can do that. You can have keys, which we're going to hear a little bit more about here soon, that aren't just numbers. They are a combination of letters and numbers. So in this item table, we've got the item number. We've got the description of the item, how many we have on hand, what the category is, and don't confuse this category as what we've been talking about up here as a replacement of the table. This is actually the category of the product, right? And then how many are in the storehouse and what the price is. It should also be noted that this is what the current price is. Because this price could change in the future, which would then mean item orders down the road might have the same product with a different price. And here's our orders table. So we've got these order numbers, when the order was done, and the customer number. Well, that's great, but how do we know what they ordered? Well, that kind of gets into this sample order line table. So this table has its own way of identifying it. It goes by the order number and the item number. So let's go back for a moment and we see 51608 was an order placed on the 12th of October, right? October? Yeah, 2015. And it was CD33. So it was a wood block set, 48 pieces. And 5 of those were ordered, and the quoted price was $86.99. Now that's great, and if you notice, there's only one of these numbers. So that means there was only one line item on this order. But the next one, 51610, you can see there's 2 of them here. So that means there's 2 line items on the same order. Of course, they're different items, and this is how we know that these lines are unique, because we've got an order number and an item number that make them unique. Because you wouldn't have an order number, let's say 51610, item number KL7825, and then the price, and then have another row of the same number item number and another number ordered, you wouldn't do that. You would just wrap it all up into one line. So that's why this number and this item number make this row unique. And that's one thing to remember, is we need to make sure somehow every row of data we have is unique. There's some way we can get to it by asking for it, and that means it has to be unique. If we didn't have this item number column, there would be no way for me to get to 51610, this particular row, without getting this row too. So that's why we had to have the item number in here too. So when I'm doing my query, I could say, hey, give me the row that has 51610 as the order number, along with KL78 as the item number. And sure enough, this row would turn up for me. All right. Now, this is an alternative orders table structure. And what's unique about this is what they're doing is they're putting one order number. So let's go back to that table we were just looking at, how we had 2 here. Now we only have 1. And they just, by doing a line break, put another item number. So in this, it's similar, except that this one really is breaking up the data. This one is kind of clumping the data together. And you can see that in that first one we looked at, 51608, has only one line. 51610 has 2 orders, 2 line items. So does 51617, also has 2 orders, line items. So this is an alternative way. Heads up, I'll tell you this, heads up, this will make more sense week 2, and something that you're going to need to kind of keep in mind when we're in week 2. So please remember that. Week 2, this is something that is normalized at a certain level, versus this is normalized at a different level. Don't worry too much about that now. Just keep that in mind when we get to the next week. This is kind of where we talk about the reason why we don't really use this alternative order number is it's difficult to track information between columns. And then how much room is allowed for multiple entries? How many how many rows should we allow in one order? If we look back this way, if we wanted to add another line item, we just add another row. No big deal. This one gets a little bit more complicated than that. Sure, we could just do another line break, but that's not really how tables in a database structure work. So that's why the question does become, how many rows, room is allowed for multiple entries? What if an order has more order lines than you have allowed room for? And for a given item, how do you determine which order contains order lines from that item? So it's always these different issues that tend to make us not use this type of setup. And again, in week 2, we'll talk a little bit more about the problems with this. Now, this is the benefits of that first order line table we looked at. Let's go way back to that, which is this one. Did I go past it? There we go. Table is less complicated when separated. No multiple entries. Numbers of order lines is not limited. Finding every order for a given item is simple. That is exactly what the benefits of that table is. All right. Now, let's go through the Colonial Adventures Tour database. We're going to go through this one, especially because it is something that you're going to use throughout your assignments. And then when we get to Silmaris, we're just going to really run through it because, again, you'll only need the information here and there. It's not that big of a deal. So this is the Colonial Adventure Tours database. It's a small business that organizes day-long guide trips to New England. The data is to be stored in a database, which is why we're here. Needed forms and reports to work with the data. again, a really common need for databases is to get reports. Gathers a variety of information on guides, trips, customers, and reservations. Now again, right away you're starting to hear some words that help you understand what you're going to be seeing. These are guides, trips, customers, reservations are categories. So the data for the guide table is we probably need a guide number. You know, something that signifies who this person is, a unique number. We need the last and first names. We need that guide's address, the phone number, and the hire date. Pretty simple employee table. So here's what that looks like. The guide number, also a combination of letters and numbers. The last name, the first name, the address, the city, the state, the postal code, phone number, and the hire date. All pretty standard. So now we need to make sure we have a trip table. What trips do we have? So in this table we need the trip ID, which is a unique identifier, the name, that location and state, the distance, the maximum group size, so how many can go on this trip, what's the maximum number, and then the trip type and the season. So here you go. This is a trip table. For the trip ID, we're using a standard number that starts at 1 and just kind of increments. We've got the trip name, the starts location, where the state is, the distance, the max group size. So again, on this one, like the first row says 10, that means we can't book 11 people on this trip. 10 is the max. What type of trip it is, whether it's hiking, biking, paddling. And then the season, summer, late spring, early fall. We've got late spring, those kind of seasons. Well, you're not going to be much of a business without a customer table. So we definitely want to have a unique number for our customer number. Last name, first name, address, city, state, postal code, and phone. Now, why can't we use like the last name as a unique identifier? Well, because there's people that have the same last name. And you can't do first name and last name because, again, there are people that have the same first and last name. One person told me, well, why not the phone number? And it's interesting is because we are getting closer and closer to a phone number being very unique to a person, especially with the mobile phone that we have going on. In fact, there are plenty of apps now that is your unique ID. In fact, when you log in, you have to type in your phone number as your login. Then they send you a text message as a way to authenticate that your phone number is actually you. And so they use your phone number as your customer number. And in this case, this was written before that time. So in this case, we actually just have a customer number. And this customer number looks like we started at 101 and incremented. Well, now we're going to start making some tables that have the relationship, bringing all this data together, right? So that's the reservation table. The reservation ID is a unique number that starts at, 1,600,001 and goes up. Then we've got the trip ID, which is one of the tables we just talked about, along with the trip date. This is the date that we're actually going to go on the trip. How many people are on the trip, what the price of that trip was, and any other fees, and then the customer number. Now remember, the customer number in this context is the customer. They might be booking more than one person. The trip guides table. Now, let me just take a moment and I will tell you, whenever you see two categories put together with especially with the underscore in the table, this is a good. Now, it doesn't mean you have to do this, right? And not every company organization does this as a standard, but a lot of companies do. A lot of places do. We will do this, and so when you see two categories that are shoved together like this as a particular table name, that means it is a table to join two categories together. In this case, we're going to put the trip ID number and the guide number together. So trip ID 1 has 2 guides. 2 also has 2 different guides, while 3 only has 1 guide. Why did we do this? I'll give you the short answer, but we're going to talk about this more in a couple of weeks. And that is, this table is actually known as what's called a many-to-many relationship. We are bringing many trip to many guides together in one table. Alright, like I said, we're not going to go too much detail in the Solmaris condominium group. It is a group that manages condominium complex. They have 2 properties and maintains common areas, also provides maintenance services, and uses the database to store information for managing operations. They have a location table. They're going to have an owner table. And here's the location and owner table examples. They're going to have a condo unit table. Remember what I told you before? When you see condo _ unit, that usually means that they are bringing multiple pieces of data together. In this case, I'm not sure that they're doing that. In fact, I think they just wanted to put a space in between condo and unit. Now, I'll tell you, this is a good example why a lot of firms, when you get with a company, will have standards, including naming standards. Because in this case, this would confuse a developer who would normally say, oh, well, then condo and unit must be 2 categories and this table's being pulled together. When in this case, it's not. It's just the name of a table. They probably shouldn't have an underscore. They should have just pulled condo and unit together. But that is the case why standards are here. So again, this is the condo unit table. It doesn't really look like it's bringing multiple things together. But anyways, service data. This is the data that's going to bring the maintenance service pieces of information together. Here's an example of that. Again, I'm not going to spend too much time on this. You only need it sparingly, but make sure you look at it in the book, understand it. Here's the service request table. So the summary for this first week is we talked about the tile distributors and that it requires these particular categories, aka tables, the Colonial Adventure Tour, and what it requires, along with Solmaris Condominium Group and what they require. That is week 1. The next video that I have for you to look at is we're going to just go over a little bit of the homework. I'm only going to take a couple of samples and kind of work them out, just to give you an idea of what's going on. But then you can take that information and do the rest. All right, we'll see you shortly in the next video.